In this unit, we will talk about equivalent fractions. In particular, we will talk about what it means for fractions to be equivalent, the equivalence of whole numbers and fractions, and how we can explain fraction equivalence in general. In grade 3, students do some preliminary reasoning about equivalent fractions in preparation for work in grade 4. Fractions are equivalent if they represent the same number. On a number line, that means they label the same point. And in a diagram, they correspond to the same length or area. Students might begin by experimenting with different representations of fractions. For example, they might take a strip of paper, fold it in half, and shade one half of the strip. Then they might fold it in half again and see that each half has been further subdivided into two equal parts, and that they can also think of the shaded part of the strip as 2/4. Note that the strength of this representation is that the amount of shading doesn't change, just the way we name it changes. This idea that the piece that represents a fraction can be further subdivided, leading to a different name for the same quantity, is key in understanding fraction equivalence in general. The number line is especially helpful for understanding fraction equivalence for fractions greater than or equal to 1. Consider the equivalence between 1 and 2/2. If we partition the unit into two equal pieces, we see the number 2/2 is at the same location as the number 1. Similarly, if we partition the unit interval into 4 equal pieces, we see the number 4/4 is at the same location as the number 1. By similar reasoning, we can see that 1 is equivalent to any fraction where the numerator and the denominator are equal. The equivalence between fractions and whole numbers is important in 3rd grade. In 4th grade, students explain why multiplying the numerator and denominator by the same whole number produces an equivalent fraction. Let's use a diagram to explain why the fraction 2/3 is equivalent to the fraction 2 times 4 over 3 times 4. Let's start with a rectangle that represents 1 that is divided into 3 equal pieces with 2 shaded. If we subdivide each of the 3 pieces into 4 smaller equal-sized pieces, then there are 3 groups of 4, or 3 times 4 equal-sized pieces that make up the whole. Each of the original pieces that were shaded is now divided into 4 pieces, so there are 2 groups of 4, or 2 times 4 pieces shaded. We haven't changed the amount that is shaded, we have only partitioned it into smaller equal-sized pieces. So 2/3 equals 2 times 4 over 3 times 4. Note that there is nothing special about this example. Let's check out another example and see how it looks on the number line. If we have 3 halves and partition each half into 4 equal intervals, the unit interval is partitioned into 2 groups of 4. Each of the 3 halves has been subdivided into 4 smaller intervals, so we now have 3 groups of 4 of these smaller unit fractions. Remember that the equivalence of these 2 fractions is shown by the fact that they both name the same point on the number line. In general, when we multiply the numerator and denominator by the same whole number, we are just dividing each unit fraction into smaller unit fractions. Since this doesn't change the amount that is shaded, or the point on the number line, the number that the fraction represents hasn't changed. Thus, when we multiply the numerator and denominator by the same whole number, we always get an equivalent fraction. Note that students can reason about equivalent fractions using just the meaning of fractions. In particular, in 3rd grade, they won't understand an explanation that uses fraction multiplication because they won't study that until 5th grade. Once in 5th grade, they can also understand fraction equivalence in terms of multiplying by 1.